Hi Unmil, Richa, Vijender, how are you guys? Okay. So I have somebody on Android, so I'm not sure who this is because the name is not coming up. Who is on Android attendee? Richa says, okay, Vijayshri is there on the Android. Okay. Vijayshri, but can you see my screen or you won't be able to see? Okay, perfect, good. So we have Vijayshri, Richa, Unmil, and Vijender. Thank you all for joining. And I know, this is a weekday, so really appreciate for you being here. So today I will cover two very, very important topics. The first one is called the recommendation engine or the market basket analysis. And I will give you some motivation behind, where exactly we use it. And the second topic that we'll be covering today is time series analysis, which is nothing but forecasting, right? And both of these are done in R, but I will give you some motivation for the market basket analysis in Excel as well. So at least you have the basic concepts on what we are doing and why we are doing that, right? Now, before I move on, let me just pull up some of these e-commerce websites. So let me just show you Amazon, for example, right? Okay, this is some fake. Okay, so while it's coming up, so you'll notice that if I, let's say, if I search for microwave, right, or let's say if I search for maybe a phone. So let's say if I'm searching for Samsung Galaxy, right? So Samsung Galaxy J7 is the phone that I'm searching for, and I click on the phone, right? And if I go down in this website, so you obviously see the product that they are selling, and then what they have over here is frequently bought together, right? Um, Let me just grab my pen as well so you guys can see it. Right. So for example, when I search for Samsung Galaxy phone, I see this area as well, right? Where I'm putting the yellow marking that they will say frequently bought together, right? So a lot of times those items are very, very intuitive that if I'm buying, cell phone, I would be interested in buying the glass covers to protect the screens. I would be also interested to buy, some other devices and accessories with that, right? So this is nothing but what we call as a market basket analysis or the affinity rules that if I have done this, I will also be likely to do this other activity, right? So it's actually leveraging very, very closely the concept of conditional probability that if you have done this, what are the other sort of activities that you'll be participating in, right? Now, where do we use a market basket analysis? We use in a lot of different places. So, for example, when I'm looking at a retailer like a Walmart or Target or Big Bazaar over here, right? So, one of the key concept that they use to figure out the product assortment on the shelf space will be driven by the market basket analysis. So, which are the products which are sold together? Which are the activities which are done together, right? So that's why the name market basket, because you have a basket, and in that basket there are certain products that will be always carried together, right? There is one famous, very, very famous example, and I think it's more like an urban legend in my opinion rather than being truth, which is that a retailer which is supposed to be Walmart, and so they were actually trying to figure out what sort of spend pattern the customers have in a store like Walmart, right? So they noticed that whenever they sold diaper, right? the beer was, some sort of beer was also bought together with the diaper, right? So somebody went ahead and took a look into, why this might be happening. So they actually figured out that, on Friday evenings, generally most of the times, whenever a young father is coming in, they will be coming in primarily to pick up the diaper for the kid in the home, right? But as they are there, they would also pick up the beer, right? And because they don't have, sort of like, I mean, they won't be able to go out because of the small kid at home. So they're actually, having something for themselves as well, right? So they actually started to put, diaper on the one side of the aisle and beer right behind that, so that you don't have to travel a long distance in the store, and you can pick up the product right there and right then, right? So what it really boils down to is that if you do a very good job in the market basket analysis and figuring out what products are sold together, you will be able to maximize the sales that you can appropriate from the customer, right? So that is the main motivation behind that. Now, why we need to have a software to do that? Because if you look at a company like Amazon or Flipkart or Target or Walmart, they have millions of SKUs or SKUs as we call them in the retail language, which is the stock keeping unit, right? So each product, and then within each product, the size of the packaging and so on and so forth. So they are really looking at a large number of product combinations that they have to look at to figure out, what sort of combinations are being sold together. So when you are a small mom and pop store, you can probably have a very good idea, right? And when a customer comes to you and you're a mom and pop store owner, you know exactly what the customer is asking for, and you know what other customers have bought, and then you can push the other product, right? But when I'm a big retailer, I mean, it's very, very unlikely that I will have that sort of visibility unless I deploy an algorithm to do that, right? So let me pause here and see if you guys see the general motivation behind a market basket analysis, right? And you'll see it in lot of different shapes and forms. And I mean, if I just name it, I mean, you'll be surprised, how many places it's being used, right? Let me give you one more example. By the way, any questions from anyone, or everybody's clear? Just let me know. So Vijender says clear, Umil says clear. Okay, good. Okay, so for example, when you go to LinkedIn, you will see another example of the market basket analysis. So let's say I click on my name, and then I look at my profile, right? So you will see, actually, let me look at somebody else. So let's say I look at Amit, right? So let's say I'm looking at Amit, right? So when I'm looking at Amit, did somebody just join? Devesh. Devesh, hi Devesh, how are you?
Hi,
Hi.
I'm good.
Okay,
Hi, hi, hi.
perfect, Devesh. So we are talking about
Okay.
the market basket analysis, Devesh, and we will build on it as we go along, right? So I'll put you on the mute for now. Okay, thank you. So for example, guys, look at this. So I'm looking at the profile of. Give me a minute, let me just clean up my screen here. So I'm looking at profile of Amit. And when I'm looking at profile of Amit, on this side you see that they are saying people who viewed Amit also viewed these guys. And obviously my name is there. Then we have Deepthi Verma, Sakshi, Raj, Zubin, Shroff, and so on and so forth, right? So basically that is the main motivation. And again, they are doing something what we call as a market basket analysis or affinity rules or association rules. It goes by different names, but the general motivation is that you're trying to establish the linkages in terms of, if a customer has done something, what is the next event that the customer is likely to do. Okay, so is this clear, guys? I mean, any other examples that you see happening where you see that they are making a recommendation based on your behavior, and that's why it's called the recommendation engine. And it really is very, very important in terms of the online space, because you don't have a salesperson, you don't have any human interface. All you have is basically you're looking at how the machine itself can make the correct recommendations for you. Any other examples where you see something like this happening, where you think, I mean, they are using algorithm similar to this to make the recommendations which may be closer to you. YouTube. So Vijayshri is mentioning YouTube, which is a great example, Vijayshri. So based on the kind of videos you have watched, they will figure out, people who watched and liked these videos, what other videos they are watching, and they will be actually able to make those recommendations, right? Netflix is one more very important example that we should think about. Netflix, I mean, as some of you may know, is an online video rental in US, right? And they are using the recommendation engine. And one of the key reasons why they have been so successful and have beaten competitions like Blockbuster in the US is precisely that they had a very nice recommendation engine. So rather than customer, sort of like walking through the store and struggling to find the next movie to watch and wasting tons of time, they're saying, oh, by the way, I know that you like this sort of like, I mean, maybe sci-fi movie. I'm gonna recommend this another movie to you, and more often than not, customers really like it, right? So you'll see wherever you go, this is what we deploy in terms of figuring out what is the right product that the customer should be given next. It could be the right product, it could be the next video, it could be the next profile that the customer should look at. It could be the next offer the customer should be given, and so on and so forth. But applications are tremendous for this, right? So let me pause here and see if everybody is with me. Okay, perfect. So there are three very important concepts for the market basket analysis, and I will give you a view of what those concepts are. And this is something that, I mean, it will be better if you can help me out with those activities as well as we move on. So the first concept, and we will be doing the market basket analysis in R. So I will briefly, walk you through the R interface and how you can do it. But very important is how we really define the rules, how we build the rules, and how do we know whether we have good rules or not, right? So let's assume a very baby case here that we are a retailer, right? And we have the transaction database. And in that transaction database, I have 5 transactions, right? So in first transaction, milk and bread was bought. So wherever you see one is populated, that means that item was sold. So I had 5 different transactions. In the first transaction, 2 items were sold, milk and bread. There was no butter, there was no beer, there was no diaper sold, right? In second transaction, butter was sold only and there was no other product sold, right? Similarly, in the third transaction, we have beer and diaper sold together. And then in fourth transaction, we have milk, bread, and butter sold together, right? So this is overall how the data looks like, right? Now, the first concept that we have for the market basket analysis is called the concept of support, right? And let's figure out how the support is defined. So let me just move the screen a little bit, right? So the support of an item set is defined as the proportion of transaction in the data set which contain the item set, right? So whenever you're saying that support of milk is, let's say, X%, what it means is that if I look at my 100% of transactions, those percent of transactions are gonna have milk bought in that, right? Which is nothing but basically you're looking at the frequency. So what percent of the transactions have milk bought? Now, why this is important, why we should look at the support, why do you think we should understand, how many items have or how many transactions have a particular item sold? What would be your guess, guys? Any ideas why this may be happening? Why we should look at support? So it's mentioned right here. So if again going back to the example that we were talking earlier, that if I have millions and millions of transactions, I really need to figure out what are the high volume transactions, right? So if you focus on this line, I really need to focus on what are the high value transactions, because I should not be going after the small ticket size or small volume transactions. Exactly. So Vijayshri says it gives percentages and it helps us focus on the key value items, because I mean if I try to figure out everything being sold together and what sort of combinations exist, I mean I may be sort of like looking at transactions which are very small in size, right? Or the combinations which are not that frequently happening, because there will be always some customers who buy things in a weird fashion, right? That there's no correlation. But we're not going after those customers. Those are outliers. We would like to understand those high value or frequently happening combinations that are there, so that we can focus on those, right? So that is the reason behind how we or why we want to have the support and why we want to use it for defining the market basket analysis, right? So let's do a couple of examples. So support of milk. So how many times milk is being bought? Total milk is bought in the first transaction, and then milk is bought in the fourth transaction. So there are two instances or two transactions where milk is bought out of the total 5. So the support of milk is 2 divided by 5, which is 40%, right? So how do we interpret 40%? That 40% of the transactions happening in that particular retailer contained milk, right? Is this clear how we got the 40% for milk? Everyone, the support of milk is 40%. Vijender says yes. Okay. Devesh, Richa, Unmil, everybody, are you clear? Okay, so everybody's clear. So let's define the support for bread. How many transactions are there for bread? Anyone? Can you give me the answer? How many transactions contain bread? Richa says 3, which is exactly the correct answer. Devesh says 3, and Devesh already has the answer 60%, right? So the total number of transactions which have bread is 3. Total number of transactions are 5, right? So the support for bread is 60%, right? All it means is that the 60% of the transactions happening in that retailer contain bread. Now, if I have to define the support for bread and butter, what does it mean? That what are the instances or what are the transactions when bread and butter both have been bought together? So how many cases are like that? Anyone? When bread and butter both have been bought together. Devesh says 5. No, Devesh, that is not the correct answer. I'm saying when bread and butter both have been bought together. So Vijender, Vijayshri, they are saying yes. They are saying 1. Richa says 1. Yeah, so that is the correct answer. So bread and butter together have been bought only in one instance, right? So the support for bread and butter will be 1 divided by 5, which is 20%, right? Now, who can give me the support for butter very quickly? So support for butter, support for milk, bread and butter, and support for beer and diapers. So let's see who can give me the answers for all three. You can do the calculation at your end, and you can give me one by one. That's fine. So support for butter, Vijayshi says 40%. Okay, does everybody agree with this? Butter, Devesh says 2 by 5. Yep. Richa says butter is 2 by 5. Okay, so everybody is getting 2 by 5 for butter, which is the correct answer. So if I just put the numbers, so that is going to be 40%, and that is nothing but 2 by 5, because there are two cases or two transactions where butter has been bought out of the total 5. So support for butter is 40%. So Vijender has all three, 40, 20, 20%. Okay, let's see. So the support for milk, bread and butter. So what does it mean? That milk was bought, bread was bought, and butter was bought in the same transaction, right? So that is what we are looking for. So let's find out how many transactions are like this. So milk was bought here, bread was bought here, but there was no butter in the first, right? So that doesn't qualify. Then the second time when the milk is bought is in the transaction number 4, which is yeah. So all three are being bought together. So milk, bread, and butter, they've been bought together in one instance only. So the support for milk, bread, and butter will be 1 divided by 5, which is nothing but 20%. Everybody agrees with this? Clear to everyone why the support for milk, bread, and butter is 1 divided by 5 or 20%? Okay. So then let's look at the support for beer and diaper. So how many times beer and diaper was bought together? There is just one instance which I am highlighting in yellow. Only one time it has been bought. So the support for the beer and diaper together is, sorry, 1 divided by 5, which is 20%, right? Everybody clear on how support is defined? Richa confirms, Devesh confirms, okay. 1 mil is fine. So I guess everybody is more or less fine with this, right? That's great. So it's very, very important that you understand also the rationale why we calculate the support. So can anybody rephrase, why we need to calculate the support level for a market basket analysis? Okay, so I have some answers. Vijender says to which products are moving together. That's partly correct, Vijender, but so Vijayshi says, what is the rationale for clubbing the variables? That's also partially correct. But the main reason is the support we need to have because we want to look at the fast moving items or high moving items, the volume items, right? So let's say if I'm looking at the milk and diaper being bought together, but there is only 1 in million probability that milk and butter will be bought together, sorry, milk and diaper will be bought together, then I'm better off not looking at that transaction at all and not building any rules on that, right? So I'm looking at fast moving items and high volume items and combinations of the products to figure out what sort of combinations exist and how we can tap those combinations to increase the sales, right? So that's the main reason behind that. Okay, now let's look at the next concept. This is again, very, very important that we understand what it is. So the next concept is called the confidence, right? So confidence is defined as the conditional probability that the transaction containing the left hand side will also contain the right hand side, right? So let's just think about it, what it means. So, and actually the technical names for the left hand side and the right hand side can also be the consequent and precedent, right? So, I mean, one is following the other. But let's just, for the sake of simplicity, we can look at the right hand side and left hand side. So what it means is what is the probability that the right hand side will happen given that left hand side is happening or has happened, right? So that is what we mean by confidence. So this is nothing but the conditional probability for the people who are familiar with the conditional probability term, right? Any examples of the conditional probability that you can give? Any examples, guys, where you see conditional probability happening? So, for example, a lot of times we say that, given that it has been raining for, X number of days, the probability of rain happening in the next day is also very, very high, right? So, given one event has already happened, I know for sure that the other events happening probability will be significantly higher, right? So, in this case, what we mean is basically that given the left hand side has happened, and left hand side could be, like given that bread and butter has been bought, what is the probability that milk will be bought, right? Similarly, given that diaper has been bought, what is the probability beer will be bought, right? So those are how we define the conditional probability. So if you look at the formula of the conditional probability, it's basically probability of right hand side happening. Let me see if I can zoom in a little bit. So probability of right hand side happening given that the left hand side has already happened, right? So if you expand this and if you talk in the language of the probability, that's probability of right hand side and left hand side happening together divided by the probability of left hand side. Or if you just simply look at how we can translate that into the support, it's basically the support of right hand side and left hand side, which is nothing but how many instances are there where right hand side and left hand side are happening together, right? Divided by the probability of left hand side, or the how many instances are there where the left hand side is happening as well, right? Okay, so Vijesh is asking what is the rationale of clubbing variables? They should be independent from each other. So Vijesh, I mean, they are not independent. So we are saying if left hand side has happened, the probability of right hand side will be significantly higher. So if they are totally independent from each other, so if the left hand side is not impacting the right hand side, Vijayshri, then the conditional probability will be as good as the probability of right hand side alone. So for example, let's say, whether it has rained in US is totally independent of whether it has rained in India. So whether or not, I mean, you give me the data point that it rained yesterday in US, what is it gonna do for the probability of raining in Bangalore? Absolutely zero. So given you tell me the information that it's raining in US, that has nothing to do with whether it's gonna rain in Bangalore or not, right? So they'll be independent. But if you tell me, given it's raining in Mysore, right? And I know Mysore is very close to Bangalore. So I will say because it's raining in Mysore and because it's raining in Tumkur, because it's raining in other surrounding areas, the probability of rain happening in Bangalore will be significantly higher. So they are not necessarily going to be independent. And that is the entire rationale of the conditional probability that given one thing has happened, given one event has happened, what is the probability the other event will be happening? Is it clear, Vijayshri, this point? Okay. So how would you define the confidence? Confidence is nothing but the support of right hand side and left hand side divided by the support of left hand side because that's in the denominator. Let's look at some of the examples, right? And let me zoom out a little bit so that we can see. Give me a minute. It's just taking the entire screen here. Yeah. Okay, I think this is decent size. So let's look at the couple of conditional probabilities here, right? Or confidence. So what is the probability that milk will be bought given the bread and butter has been bought? So if you look at the formula here, that is support of right hand side and left hand side. So that means how many instances are there when the bread, butter and milk have been bought together? What is the correct answer? How many instances are there where the bread, milk and butter, all three have been bought together? Because that is the right hand side and left hand side, right, combined together. The left hand side here is bread and butter and milk is the right hand side. So Richa is right. So there is just one instance where the bread, butter and milk, all three were bought together. So that means my numerator is 1 divided by 5. So support of my right hand side and left hand side is 1 divided by 5 divided by the support of left hand side. So how many instances are there where bread and butter has been bought together? 1, right? So that is 1. So that's why we are looking at 1 by 5 divided by 1 by 5 and that's 100%, right? Now let's interpret what does the 100% means, right? So in terms of the conditional probability and the confidence parameter that we are looking at, it says that I am 100% confident that if the bread and butter has been bought, milk will be bought as well, right? So that is the interpretation of the confidence. So whenever you see 100%, you say that, okay, I have a very fairly high level of confidence that whenever bread and butter has been bought, I'm 100% confident that milk will be bought as well. Similarly, let's do it for the diaper and beer. If I, highlight the formula, how many instances are there where we have both diaper and milk being bought together? Just 1 divided by 5, that becomes my numerator, divided by the support of left hand side or the instances where only the diaper has been bought alone and there is just one case, so that's 1 by 5 and that basically makes it 100%, right? So this is how we define confidence. Any questions guys on how we are doing the calculation or is it clear to everyone? Clear. Okay. So if it is clear, then let's go ahead and do the next one. So who can answer the question? What is the confidence that beer will be bought provided milk has been bought? Let's see who comes out with the correct answer. Confidence that beer will be bought if milk has been bought. So Vijay, she says 20%, Richa says 0%. Any other answers? So how many instances are there? So you follow this formula. So you have to look at the support of right hand side and left hand side, which is nothing but how many times both right hand side and left hand sides have been bought together. So the right hand side obviously is beer, left hand side is milk. So how many instances are there where milk and beer have been bought together? Anyone? How many instances where milk and beer have been bought together? Zero, right? So there was just one instance where beer was bought, but the milk was not bought at that time. So if you look at the formula, it's going to tell you the same thing over here, right? So you can look at, so there is zero instance where beer and milk were bought together, because here only the beer was bought, but if I look at the milk, milk was not bought, right? So zero instances where milk and beer were bought together, so that basically makes the numerator 0 divided by 5 divided by the denominator, which is basically how many instances where milk was bought, that is 2 divided by 5, but because I have 0 in the numerator, that means 0%, right? So what does it mean? That I have 0% confidence that beer will be bought when the milk has been bought, right? Is it clear to everybody how we got this 0%? Any questions? Okay, so let's do the next one. What is the confidence that butter will be bought given milk has been bought? Which just says 40%. Okay, let's see others. Vijay C says 100%. Any other answers? Unmil says 20%. Okay. So we are doing this, guys. What is the confidence that butter will be bought given milk has been bought? So I'm getting 20% for majority of you. So let's check out the formula. This is 50%. How? So how many instances are there where milk and butter has been bought together? Let's just do that math first. How many times milk and butter has been bought together? One. Only one instance, right? In this row here, where milk and butter was bought together over here, right? Only one instance where milk and butter was bought together. So that makes the denominator as 1 divided by 5 divided by how many times milk was bought? Milk was bought 2 times. So that is divided by 2 by 5, which is 50%. I guess, I mean, everybody or most of you didn't get this answer correct. So is it clear now or still a little bit confusing? Yes, she says it's clear. Okay. Yeah, so I mean, just follow the same math. I mean, don't get confused with anything. So I mean, just follow the same math and be a little bit slow in the calculation. You'll get it right. So let's do the last one. Confidence that butter will be bought given the bread has been bought. Who wants to answer this one? Let's see. Are you guys able to see my Excel file or shall I zoom in? Because it may be possible that you're not able to see the figures correctly. That's why. So Vijay, she says 30%. Devesh has 30. Let me see. Let me just go back. So I got multiple answers at the same time. So Vijay has 30%. Devesh has 33.33. Richa has 20%. Okay. So any other answers from anybody else? So Richa, I'm sorry, Vijayshi now says 33.3%. So let's just check it out, what this number is. So the correct answer is 33.33%, or you can say 33%. How? How we got that? So let's look at the formula. So how many times bread and butter has been bought together? Bread and butter has been bought together in one time only, right? So one transaction out of the five transaction, bread and butter has been bought together. So that makes the numerator as 1 divided by 5. Denominator is how many times bread has been bought. So bread has been bought three times. So that makes it 3 divided by 5, right? So if you look at the math, so that's 1 by 5 divided by 3 by 5, and that's how you get the 33.3%. Is everybody clear on support and confidence so far? Or any questions? I'll be more than happy to spend some time. Clear? So these are, guys, very, very important concepts anytime you're doing a market basket analysis. And as we talked about earlier, market basket analysis or the recommendation engine is holy grail of the machine learning and the recommendation engine, and any sort of upselling and cross-selling in the absence of the sales agent. And you'll see tons of application. I just gave you like the tip of the iceberg in terms of the application, the way I showed you in the LinkedIn. Some of you gave examples of the YouTube, the Facebook, Amazon, Flipkart. Everybody uses this. All the e-commerce companies are using this, right? So it's very, very important that you have a good hang of that, right? So let's talk about the next concept, which is lift, right? So it's a little bit more complex compared to the other one. So I'll just let you guys read it for a minute, right? So just digest what it says in the red font, and then I will explain in my own word. So Vijayshri, remember the comment that you were having earlier? This is where your comment will be relevant. You were saying, I mean, are they independent or not, right? So just read this line and this will tell you exactly why I was saying that the confidence will be capturing the correlation or the dependence on each other, right? So just look at the lift, the definition of the lift, which is highlighted right here. Okay. So lift, I mean, if I just read out loud what is written in the red font here. So lift is defined as lift AB and is given as the ratio of the observed support to the expected if A and B were independent, right? But very, very clear, definition is if you look at the probability definition here. So lift of A and B is defined as probability of right hand side given that left hand side has happened divided by probability of right hand side. If, to Vijayshri's point earlier, if there is no dependence between the right hand side and left hand side, the probability of right hand side given the left hand side has happened will be exactly similar to probability of right hand side. Going back to my example, whether it has rained in the US has nothing to do whether it's going to rain in Bangalore or not, right? So if you tell me that it is raining in US right now, it does not change the probability of rain in Bangalore. So in that case, the numerator and the denominator will be exactly the same. So the numerator, which is the probability of right hand side given the left hand side has happened, will be exactly similar to probability of right hand side, which is that they are independent from each other, and then this number will become 1, right? Because both numerator and denominator are the same, this will become 1. Is this clear, the concept of lift? Okay, good. So this is the third very, very important concept that we should look at. So Vijayshri says, can you explain again? Sure, Vijayshri. So remember, you only made the comment that, I mean, if they are correlated or not, whether they should be independent or not. So in this case, what we're testing out here is, and actually let me write down because I think that will be more clear, right? So I'm saying, so what is the probability that it will rain in Bangalore given that it has, or it's raining in USA? right? So this is basically what your numerator becomes. And then you're looking at the probability of rain in Bangalore, right? My point here is that unless there is some severe weather pattern which is impacting everybody across the world, whether or not it has rained in US has nothing to do whether it's going to rain in Bangalore or not, right? So in this case, what really big, so the conditional probability factor that we have in the numerator is nothing but what is the, because the whether it's raining in US will not change anything in terms of the Bangalore. So the numerator is nothing but the probability of rain in Bangalore, right? And denominator remains the same, which is the probability of rain in Bangalore, right? And that makes it basically, oh, looking at something. So rain in Bangalore, and that will make it basically, if you look at this one, it will be 1. So the numerator is the same as denominator, and you will have that lift as 1, right? So in other words, what is the lift trying to capture? Lift is trying to capture, is there any correlation between the right hand side and left hand side? Are they totally independent or not, right? So if they're not totally independent, you will see lift to be coming out to be higher than 1, because you're saying given you tell me left hand side has happened, there is a higher probability of right hand side to be happening. That means that lift is going to be higher than 1. If they are totally independent, like I mean the example that we did, whether it's raining in US has nothing to do with whether it's going to rain in Bangalore, then the lift will be equal to 1, which means the events are totally independent from each other. Is it clear to everyone, or shall I explain now bit more? Unmil says clear, Vijesh is clear. How about others? Devesh is fine. Richa is clear as well. Okay, so let's define the first one here, right? And follow the same math as what we have done here. So this basically you'll have to look at this question. If you're defining the lift of A and B, Vijender is clear as well. So if you're looking at the lift of A and B, that's nothing but the support of A union B, right? Divided by support of A times support of B, right? A union B is nothing but, where both events are happening. So let's look at the first map. So that means, how many instances are there where milk, bread and butter, they're all bought together. Milk, bread and butter all bought together will be only one instance where I'm saying yellow, where I'm putting the yellow color. Only one instance where milk, bread and butter has been bought together. So that basically, gives us this part. I'm going to draw something. So that is basically this part, support of A union B, divided by support of A times support of B. What is support of A? Basically support of butter and support of milk and bread together, right? So let's look at the math now. Again, one more time. Divided by support of, right hand side, or you can assume left hand side first, milk and bread bought together. That's basically this and this, right? So there are two cases where milk and bread is bought together. So that makes the next parameter here as 2 by 5. Similarly, support for butter. Now let me actually use a different color for butter. So support for butter is gonna be, but it's gonna overlay, right? So that's why it's very hard to do. So support for butter is also, you can see that it's 2 by 5. So two instances where butter has been bought. Similarly, two instances where milk and bread was bought together, milk and bread here. So that's 1 by 5 divided by 2 by 5 times 2 by 5, and that comes out to be 1.25. Anytime you have a lift of more than 1, that means there is some correlation of the variables to each other, and you should keep those product combinations in the mix, right? So that is the key takeaway from here, that the lift has to be greater than 1 in order to conclude that there is something to do with the, that the left hand side and the right hand side, or the antecedent and precedent are kind of correlated to each other, right? Now, who can answer the question, which is, what is going to be the lift for bread and butter? So follow the same math which I have highlighted here in the yellow color. Take your time. Let me know if you can answer this. What is the lift of butter given bread? So you have to first look at the support of A union B, which is, how many times both bread and butter is being bought. So that becomes your numerator divided by the total instances. Then you have to look at what is the support of butter only times what is the support of bread only, and then that will give you the denominator. Shall I show, or are you guys working on it? Okay. So I think people may have some doubts around that. So let me just highlight how we have got, right? Same formula. So look at this area right here, over here, right? So this is how we are defining that there. So what is going to be support? Okay, so I have some answers. So Vijay, she comes out with 8.83. Okay, good. So let's see how, we got this answer, right? So support of A union B, basically how many times bread and butter has been bought together. So bread and butter. So there is just one case. Bread and butter has been bought together, right? So that gives me the numerator, which is 1 divided by 5. Then I'm looking at how many times bread has been bought. So bread has been bought. Let me use a different color here. Bread has been bought 1, 2, 3. So bread has been bought in 3 cases. So that gives me the next parameter, which is the 3 by 5. Right. Now let me look at the butter. So butter support, how many times butter has been bought? Butter has been bought 2 times over here and over here. So that gives me the next parameter, which is 2 by 5. And if I do the math, I will get to the answer. But is this clear? How we got the lift for butter given bread has happened to everybody? Okay, so now let me clear up and then highlight the answer. The answer is 0.83, as Vijay correctly pointed out. So that is 1 by 5 divided by 3 by 5 times 2 by 5. That gives me 0.83. So don't worry. I will send you this file, and this will be there on the website as well. We'll upload all the previous session as well if you missed out anything uploading there. So you will have it. You can practice later on at your leisure, right? But at a high level, is everybody clear on what the market basket analysis is, what are the potential usage, and what are the top 3 parameters that we have to look at? So just like you guys did in the logistic regression like Gini and KS, these are the Gini and KS for the market basket analysis. We don't have anything called Gini and KS here, but we have support, confidence, and lift. So let me pause and see how well people are able to follow so far. So Vijender is asking, what does 0.83 mean? They do not have a correlation. That's exactly right, Vijender. So that means, that I can consider them to be non-significant. So if your manager comes and says, no, 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 if anytime somebody is buying bread, you should also push for butter, I'll say no, because the lift is not greater than 1. That means, there is not enough statistical evidence to say they are being sold together, right? Any other questions? Is everybody clear? Okay, perfect. So I will switch gears now and I will take you guys to R where we will be doing this. So there is a data and I will show you that data when I import the file. So all these steps, the basic steps you will do anyway. So you have to set the working directory. So you just set up your working directory. We have done it a number of times. So the data that we'll be using here is called retail data .csv, and basically this has three different transactions which are happening. In transaction one, product A, B, C, D, E are there. In transaction two, some other products are there, and so on and so forth. And then we are looking at how this impacts, what is the third product that is being sold. So let me just import the file and then I will show you. Right, so I have gotten the file and I will open this file. So you can see here, right? So one of the basic things, so focus on this table right here, guys. So one of the basic things that we have to do in the market basket analysis is that you have to have transaction ID, just like the small, very very babyish case that we did in Excel. You have to have the transaction ID. You have to tell what was the product A. So I'm using, just for the sake of simplicity, A, B, C, D, E, F, right? So you can say, for example, cosmetics, you can say baby products, you can say soft line, you can say electronics. So imagine all of those products are here, but just for the sake of simplicity, we are saying A, B, C, D, E. Similarly, the next product, which is the product 2, is E, F, G, H, I, J, so like that, right? So, sorry, H and I are not there. H and I are in product I, product 3. So H and I are in product 3, the rest of the letters are in product 1 and product 2, right? So this is how the data looks. Any questions on the look and feel of the data? Is everybody clear on this? So if you want, you can actually do a quick summary of this data, right? And it will tell you exactly what we are looking at. So, okay, so for those of you who are a little bit comfortable with R, I mean, you can look at this table, for example, and it will tell you very, very clearly that over here, I mean, you are getting the entire view. So there are, product A. So if I'm looking at the product one, A was sold 2938 times, B was sold 3024 times, C was sold 3047, D was sold 2946, and so on and so forth. Similarly, in product two, which is the EFG, these are the times that the product EF and G were sold together, right? Then finally, I have the product three, which is the HNI, and I'm looking at how many times they were sold together. So in this exercise, what we'll be trying to do is we'll be trying to figure out, if I know what was the product one and what was the product two, what is the probability that product three is going to be HNI? What is the probability that product, what sort of association we build to find out, whether HNI will be sold, right? So this is how we do it. So let me just go back to the R code. So head, tail, summary, you guys know, I mean, we have done it a number of times, so you can just do it again to sort of like visualize the data and see how the data looks, right? So the summary has been generated. So you can see, head will give us top 6 rows, tail will give us bottom 6 rows, summary will give us the overall summary that I just plotted for you guys, right? So here again, you can see the frequency count. So if I have to ask anybody here, what is the support of A? What is the support of A? Can anybody just give me very quickly how they will get it? Don't tell me the final calculation, but just tell me how you would get the support of A. If I tell you there are total 12,000 transactions, which is the number of observations, how would you get the support of A? So support of A is going to be, guys, nothing but how many times exactly? Yeah, so Vijender has the correct answer. So support of A is going to be nothing but 2983. So there were a total of 2983 transactions where A was sold, divided by the total number of transactions, which is 12,000. Is everybody clear on this? How we got support of A? But we don't have to do it manually. I'm just telling you, I mean, what if you were to do manually, how you will get it, right? Similarly, the support of D will be 2946 divided by 12,000, right? Clear? So that's how basically the support is calculated over here, right? But we'll just let the software do it for us, right? Now the package that we'll be using here, and like any time we discussed earlier, If you don't have this package installed, you have to install this package. So the package is called A rules, which is a short for association rules or affinity rules. It goes by a number of different names: association rules, affinity rules, right? Market basket analysis, recommendation engine. All of those are the same thing, but the package which is there in R to do this, it's called the A rules, right? So make sure that you have this package installed before you load up in the library, right? So I will go ahead and now call this package in. So I've done it, right? Now in this one, what we are doing here is, in this section of the code which I'm highlighting, so let me just wait for it to refresh on your screen correctly. Yeah, okay. So in this section, all we are doing here is, for people who are comfortable with R, is basically we are changing each of these factors to categorical. So we are saying as dot factors, which is basically changing them to the categorical or the character, because that is how we will be looking at. So, so just in case if R was not clear whether A is categorical or character variable or not, we're just clarifying that, yeah, that A is a categorical variable, right? So we're just basically saying for I equal to 1 in 1 to n column, which is a number of columns. So for each of these columns, go and change each of those columns to factors is basically what we're doing in this line of code. So don't sweat if you don't follow it, because that is just changing it, and then you can confirm that all of these variables have been changed to factors, right? Which is necessary for sort of telling R that we are looking at the factors, right? There you go. Okay. Now the algorithm that we actually run to get the market basket analysis is right here, where I'm putting the square brackets. This is the real algorithm. So everything else was sort of like the pre-processing. So the function that resides in the A rules library is called A priori. A priori is the one which will build the market basket rules for us. We will tell the name of the data, which is the sample data that we have created. We have taken a sample of the data. We're not running on the 12,000. We're running on 8,000. So we have just created a sample of the data. And then in the next, you are passing on the parameter. Parameter is a list of the key factors that we should be looking at. So for example, here we are saying support has to be 0.005. This is in fraction. So if you multiply this by 100, this will give you the percent, right? So we are saying at least 0.5% of the transaction should have that sort of rule, right? So that is what we mean by support. And confidence, we are saying, has to be at least 0.1. So if there is a rule which has confidence lower than 0.01 or support lower than 0.005, let's not consider that rule. I'm not interested in those rules where the support is not at least 0.005 and the confidence is not at least 0.01, right? So that's what we are specifying here, right? And in the next line, we are saying build the rules with the minimum length of 2, meaning at least we need to have 2 products in the rule. So I don't want to say that, if you don't sell anything, you're gonna buy product A. So at least have 2 products in the rule that we're building, which is the min length equal to 2, max length equal to 3, meaning at least have at max have 3 products in the rule. So you can say when A was bought and B was bought, the chances of H being bought is this, right? So at least have 2 products and at max have 3 products, right? Appearance, if I don't tell the appearance, what it's going to do is basically it will not differentiate between the right hand side and left hand side. It will say even when H was bought, what is the probability that A is going to be bought, right? Which is sort of like, so if I don't specify this, it's going to look in both ways. So if H and I were bought, what is the probability that A, B, C, D and all of those items were bought, right? So here I'm specifying, no, let's not do that. Your right hand side will always be some combination of H and I. So your left hand side can have any product that you're looking at, but your right hand side will always be H and I. So I'm saying, you tell me if left hand side has happened, what is the probability that the right hand side will be happening, which is H and I will be bought, right? Is it clear so far, everybody? Any questions? Let me know, guys, if it is clear or not. So Vijay, she says, okay, no questions, one mail is clear. Fine. So let me go ahead and run this. So I'm, storing that in an object called basket rules, and then I will be doing the summary of basket rules, right? So it gives you the overall summary of what is the support, so the minimum support in the rule, the confidence and lift, right? So the same parameters that we talked in Excel, none of these things have to be manually calculated. R will give you all of them, but just like we do in the rest of the course, we want to show you the underlying magic before showing you how to get the calculation done in R, right? So now it's telling you that the minimum support I have is 0.03, the maximum support I have is 0.174. So what does the maximum support of 0.174 mean, guys? So for one of the rules that R has built or the algorithm has built, one of the rules have 17.4% of transactions following that rule, right? And we'll take a look in a short amount of time, what that means. So then basically then what we're doing is we are saying inspect basket rules. So whatever rules you have created, I want to see those rules, right? So let's go ahead and run this and see what comes out. So if you look at this, it's giving you all the rules, right? And the interpretation is very clear because you have done this exercise in in Excel. That left hand side is one. So basically it says when product A was bought, when product A was bought, what is the, so the rule that we have here is when product A is bought, what is the probability that H will be bought? So it has the support of 0.12, confidence of 0.49, and lift of 1.008, right? So this gives you that rule. So for example, if I'm a store manager and says, okay, by the way, if somebody has bought A only, shall I act to push product H or not? So it's basically giving me the support, confidence, and lift for that strategy, right? So there are fair number of transactions. So there are in fact 12% of the transactions where A and H were bought together, and I will be 49% confident. So if a product A was sold, I'm going to be 49% confident that product H will be sold as well, and the lift is higher as well, right? So that means there is a significance, and they're not clearly independent. But the confidence I have is 50%. So it's basically yes or no. It may be sold, it may not be sold if product A is sold, right? Clear? This one line. Similarly, you can look at the other lines. You can go rule by rule, and you can see the rules get, a little bit tricky as well. So, for example, in this rule right here, it says, I know that product A and product F have been sold. So, what is the probability that product H will be sold? So, they are now, the support says 0.4%. So, there are 4% of the transactions where product A and product F were sold, and then product H was sold with 51% confidence and with this sort of lift, right? So this is how you will look at it. But wait, there's a better way. We can actually go ahead and run the next line of code, which is I want to look at only those where the lift is the highest, because ultimately, remember, lift is the one that tells me whether I'm gaining something or not. So I'm gonna sort it, and now this is giving me the rules where the lift is the highest and rank ordered by the lift. So here the lift is the highest. So this rule is going to be the most important rule for us, where product B was sold and product F was sold, then product H will be sold. So there are 4% transactions where it happened. There is a 52% confidence and there is 1.07% lift, right? So for each of these metrics, support, confidence, and lift, we generally want to have them as high as possible. So they should be as high as possible in most cases, right? So that is what it means by support, lift, and confidence. So now we can represent this information pictorially. So there's a library called A Rules Viz. So if you install and run that, then you can actually plot the rules as I have done here. So I will go ahead and rerun it, and this will create very, very good looking charts, which makes your job very, very easy, right? So in this chart, it's plotting all the three parameters. So confidence is here, support is here, and lift is in the color, right? So because I mentioned that you should have as high as value possible for each of them. So the rules which are on this side give you the best rules. because the support is the highest, confidence is the highest, and the colors are the darkest, and that means all three parameters are very favorably placed. So you'll pick some of these rules. So for example, if I'm Amazon and if it says A, B, and I, right? So so for example, let's say one rule was A, B, and I. So if a customer has bought A and B, I should push I, and that rule was in this corner right over here, right? So what will happen now is that the moment customer says, I'm buying this and I'm buying this, if I'm Amazon, I will immediately push I. Oh, by the way, customers who bought A and B together also bought I, or frequently bought together, or customers who viewed A and B also viewed product I, right? So you see how it happens in reality. Everybody's clear how we are using support, lift, confidence, together to figure out what product I should be pushing to the customer, given that they have already bought certain products or already showed interest in certain products. Yeah. So Richa says yes. Vijender is clear. Okay. 1 mil, yes. Great. So that's great, guys. So I mean, at least you know in principle how these things happen in reality. So there is one more fancy chart which is a little bit tricky. So I'll probably throw this as a challenge to you guys to figure out what it means, right? So wait a minute. What happened to my window? Okay. Um, fine. Okay, good. So this is the chart that I was talking about. So you can take a look at this chart, right? And it's already opened somewhere. So you can look at this. I mean, this is a little bit like an eye chart, but this tells you a lot of information in terms of what really happens and how these different things are sort of like behaving to each other. The interpretation is the same, but this is a very complex chart for me to explain, but very good if you understood and you can sort of like use it for your presentation. It really conveys a lot of information, but because of the lack of the time, I will not necessarily go and explain piece by piece. But you will have all this in the video, and you can have the code as well when you're running it. You can see how exactly it is happening. But basically, the bottom line here is that the arrows are pointing towards the rules. So if I have bought product F, then how much probability it is that I will be buying product B, and then from there it's connecting to product 3, and so on and so forth, right? So that is how basically it's done. So let me stop here, and there I have one more topic that I will be covering, which is the forecasting, right? So let me stop here and see if everybody is clear or any questions from anyone. All clear? Okay, so then let's move on. Then let's move on to the last topic that I'll be covering with you guys, and that will cover my portion. And Amit will be having the discussion on SQL tomorrow. SQL meaning SQL tomorrow. So that will be for his, you know, uh, course curriculum that is remaining. Then we'll be done, right? And then we'll be able to wrap up the class. And we will be having the project sent to you, and we'll be explaining the construct of the project as well. So that will be coming in your direction, right? So this is about the forecasting, and forecasting, as we talked earlier on when we started the course, is when you want to tell what exactly is going to happen in future, right? So based on the trend that you see happening now, what is it that you can see happening in the future? So the package that we use for the forecasting is called ARIMA, and the the package that we used for the forecasting is called the forecast. So this is the package that you need to install if you want to do the forecasting in R, right? And we are working with the sales data here, and I will show how that sales data looks like. Normally you do forecasting anytime when you want to see what the trend may look like, and you do forecasting on a time series. So when you have the time on x-axis and some variable on y-axis, and there's a certain trend happening, you would like to know what sort of trend can I expect in the future, right? So that is the basic motivation of the forecasting. So let's load up this data. and see what this data looks like, right? So it has been loaded. So if I go and pull up this, so right now you can see on your screen, I'll just give it a minute to refresh. There you go. So you can see on the screen I have the sales in dollars, right? So there's no other variable. So, but I know that these are by time. So basically this is 1 month, this is 1 month, and so on and so forth, right? So I mean by different months I'm plotting these sales. So in the next step, what I'll be doing here is to go ahead and add the months, uh, which is being done over here. So I'm saying sales, and we are using a function called TS. TS is a short for time series. So we are saying that, okay, go ahead and add the timestamp, and looking at basically first column only, because there is just one variable here, first column. So add the timestamp there and start with year 1995 and have the frequency 12. That means it's a monthly data. So starting at 1995, I'm having monthly data. So the data that we have seen here, 169 observation. So this basically we have 169 months of data that we're looking at, and we would like to make some projections or forecast based on that, right? So this is the underlying data. Let me go ahead and add the timestamp so that you guys can see, and then I will plot it one more time. So if I add and add the timestamp as well, this is how the time series data looks like, right? So everybody is familiar with this. I mean, you would have seen this, right? That you plot certain things over a period of time, right? So this is the time on the x-axis, and then you have some parameter. In this case it's sales, and we are plotting and we are seeing there's a certain trend, right? So the trend looks like this. So our objective here is what is it that we can expect to be happening beyond the point where you have the data, right? Everybody is clear on the case so far? Okay, perfect. So one very important concept in any sort of time series is that a time series consists of seasonal trends, it consists of the long-term trends, and it consists of the random noise. So the function that basically breaks up all these different trends, it's called the function. The name of the function is called decompose, right? So let's go ahead and run it, and you'll see magic happening. This is really, really, I mean, very, very important, right? So if I use this, and I'm going to call it in the variable called apps, and then I'm going to plot apps. Let's see what happens. And then I will zoom this chart, right? So you see that it's telling you what was the overall trend, observed trend over here. So this is the observed trend. So it has broken the observed trend into three different parts. Then the first part here, the three different parts. The first part here is the trend. So the natural organic secular trend over a period of time, which is higher. Then there is a seasonal trend, which basically seasonal trend meaning it keeps on repeating. So because of the seasonality, can anybody give any examples of seasonal trends that you have seen anywhere? Any sort of seasonal trends? Any guys? So Richa says Christmas time in the US, right? Exactly. Thanksgiving sales. So you'll see that, I mean, everybody's super busy, all sort of merchandise being sold during the Christmas time and everything. And then comes February and there's hardly anybody in the mall, right? Similarly, the school reopens, Vijay is talking about, there's a big rush for the notebooks, the pen, all sort of stationeries being sold in high numbers, right? So that is the seasonality part. So any sort of time series that you have, these are the different trends which will be impacting. So the first trend is overall growth. So for example, we can say overall sales in the US retail market has been growing at 3% per annum, right? So this is what the 3% will be capturing, overall growth over a long period of time, right? This is your fall season, back to school or Christmas or whatever you want to call that. Like all sort of seasonalities are baked in this time series component, right? And the third one, so this is number two, and the third one is the random thing. Random meaning, I mean, you really cannot predict. So random meaning, like, I mean, there was a cyclone, or there was an earthquake, or there was some sort of tornado or whatever, right? And basically, let's say there was some event, like, I mean, some terrorist activity or something like that, right? Those are the things you really cannot predict. So that's why we say when we are building a time series, we don't have any control over this. We adjust for the seasonality, but we predict, the general trend over a period of time, and this is what the forecasting will be helping us. But it will try to bake in all the three components and tell you, what is the trend that you can expect. So let me pause here and see whether everybody's clear on the motivation of time series and what are the different components of time series. So first component, the general organic trend over a period of time. Second component, seasonality. Third component, the random factors. We do not do anything about the random factors. Seasonalities will adjust and then we'll predict for the long-term trend. Okay. So let's move to the main R window again. And after you have understood the prediction part is really simple. I mean, there's a lot of theory behind that. So there are two components which are the auto regressive and moving average. So basically ARIMA, if you look at the full form of ARIMA, right? So this is what we use for the time series for forecasting. Auto regressive, moving averages, right? So auto regressive is the AR part, moving averages is this one, and then in the middle you have integrated, right? So that is the full form of ARIMA. So auto regressive integrated moving average algorithm, right? So which is a mouthful. So I do not expect you to remember all of this, but at least remember that there are two components, auto regressive and moving averages. And what does the autoregressive component does is basically it looks into, so because it's a time series, so it says whatever happens in the t time period is going to be a function of, what happened in the t minus 1 time period. And similarly, t minus 2 time period and so on and so forth, right? So that is the autoregressive component. The moving, yeah, so that is the AR component. The moving average component is, if T cannot be explained by T minus 1 and T minus 2, whatever is the remaining one, which is basically called a white noise. The technical name for that is white noise. I mean, it's a bit technical for the discussion today, so I'm not going to cover that, but it's called the white noise. And that is basically, it's looking mostly in the error term. So basically it's saying, whatever cannot be explained in time period T, that error is a function of error in t minus 1, and that is a function of t minus 2 and so on and so forth, right? But I will save it for later sometime, probably in more advanced version. But how do you do the time series modeling here? All you have to do is to use a function called auto arima, right? It's called auto arima. You don't have to worry about whether I have to use AR, because when you're building the time series, you can look at different components. So you can say I'm only building an AR model, or you can say I'm only building a MA model, or you can say I'm building ARMA model, which is basically not integrating, which is basically adjusting for the trend in the data, or you can say I'm building ARIMA model, right? But forget about all of that. You just use a function called auto.arima and specify the data on which you want to build the forecasting, right? And it will automatically fit the best model for you. Automatically, it will give you the best model. You don't have to struggle through, what the AR, what the MA, and so on and so forth is. You can just fit the auto arima model. So let's go ahead and run it. Yeah. And then we will predict, I mean, we will show the AR model here, right? So I built the AR model, or I have built the auto arima, and it has generated a model for me. And that model is the 110 model. 110 model basically AR, auto regressive term is 1, right? And moving average term is also 1, and then you have the differentiation part as 0, right? So that is the ARMA model, and then basically it's showing, the what are the coefficients and so on and so forth, right? But we really have to do this because when we are doing the forecasting, we just simply predict using the model. So let's go ahead and look at the model. So now what we are doing over here is we are saying confidence interval of the ARIMA model. So it will tell me, what is the confidence interval that we are having this. And then once you have the model, you can use function called forecast and specify the time period. So because I have built a model, I'm saying, using this model, predict the sales for 20 periods forward, which is a 20 months forward, using the model that we have already built here. So the model that we built is the ARIMA model, right? The model we have built is the ARIMA model. So what we are saying is use this ARIMA model and do a forecast. and do a forecast for 20 time period and plot this forecast as well, right? So let me go ahead and run all of them. So we have already done it, and we will just do the forecast. So if you look at the table first, it has given you a forecast and it has given you the confidence interval for the forecast, right? So basically, if you look at this one, so it's saying, the forecast for February 2009 is this with 80% confidence interval. So 80% confidence interval, the sales could be 1024 or 10449. Similarly, with 95% confidence interval, the sales could be 109 and 104 and so forth. And it does it for several months, right? But it's much easier to look in terms of the plot, right? So if I go and look at the plot, right, over here, you guys see that it has done the forecasting bit for you. So the blue line is the average forecasted sales, and then these are your confidence interval, right? So this basically it's saying that if I have to be, so the lower confidence interval is obviously for 80% because I'm not gonna be that sure, So with the 80% confidence, the sales will be, between this range and this range, and with 95% confidence, let me use a different color, the sales will be between this range and this range, but the average predicted sales is going to be the blue one, right? So this is how you use the ARIMA in R, and you can do the forecasting, right? So very quickly I covered this. This is a concept which is a little bit more technical. So if any one of you is interested to know a bit more about or go in the AR, MA, and all those components in details, I'll be more than happy to set an offline session with you, and then we'll be able to explain you, right? But I just wanted to at least make you guys aware that this exists, and all you have to do is to use the function called auto arima. But believe it or not, I mean, majority of the analysts working in the analytics industry do not know how to do it, right? So I just wanted to at least give you guys, quick preview of that so that you are fully aware of that, right? But all the key tools and techniques that are being used in the industry right now, like regression models, decision tree, clustering, segmentation, market basket analysis, probability theory, basic statistics, all we have covered in great details. So this, I just want to make sure at least you have a high level sense. So let me pause here and see if there is any question, comments, thoughts from anyone. So, okay, so I have Vijay Shri confirming no questions, Vijendra no questions, okay, fine. Anybody else, anything that I can clarify? Good, so if no questions, then I will stop the session today here. And as we mentioned earlier, guys, I mean, anybody who missed out the classes earlier on, you guys have access to join any future webinars, any future classes that we have whenever your schedule permits. We'll keep you in the CC with the next round of the schedule of the classes. So feel free to pop in there, right? So there's no sort of like limit on how many times you can attend. So if you have to attend the logistic regression session one more time, you are more than welcome to join in, come and join in the live webinar, right? And obviously you're gonna have the videos and everything saved with you, so you can actually refer to them. And wherever the notes are not there, we will upload all of them on the website, so you can keep on referring to them as well, right? So with that, thank you guys. It has been a great experience for me working with all of you and getting to know each of you a bit better. It's been tremendous learning for you guys. I am assuming, I mean, these are not easy concepts to grab, but you have done quite well and being very, very regular, most of you in the classes. So thanks a lot and really appreciate all your help and support. Talk to you soon. Thanks. Bye. Tomorrow, Amit will be there in the sequel. So make sure that you join that session. Thank you. Bye-bye.